Hi, this is Shreyas. I work at Chronosphere, which is a startup focused on kind of cloud native monitoring that scales reliably. In the talk that I'm going to give, I plan to speak about some of the most recent advances in Prometheus and open metrics um, around kind of bringing together metrics and tracing using exemplars. Specifically, I'll kind of be going over advances in the community and how they can be leveraged for like a couple of specific use cases for root cause purposes. Anyone who's familiar with Prometheus and has been on call should enjoy this talk. So hope you enjoy it. Yeah, welcome.
Hi, everybody. My name is Shreyas. So I'm glad to be here. So today I'm here to kind of talk about like how we can do like comprehensive observability of microservices using kind of deep link metrics and traces. So the talk is basically going over some of the latest advances in the areas of like bringing kind of metrics and traces together to uh, help like do better root cause analysis. Um, So a little bit about me. I'm a technical lead at Chronosphere, which is basically a hosted metrics and monitoring platform, kind of tailored to large scale, like high throughput use cases. It's built on M3, which is an open source time series database, which kind of acts as a Prometheus remote storage backend. Prior to this, I was on the observability team at Uber, where I used to work on kind of like monitoring, alerting, and dashboarding, monitoring, alerting, dashboarding. So kind of the agenda for today is kind of first start going over with observability signals, um, just to kind of give a quick overview. Then follow that up with kind of what happens when you get alerted, like what the on-call experience currently looks like, and kind of setting up kind of what ideal on-call experience should actually look like. We're going to follow that up with some of the latest work that has happened around kind of deep linking metrics and traces together using exemplars. Uh, and finally, we're going to kind of walk through a particular use case where we'll show you how you can kind of jump from an alert directly to like a trace request comparison, which just hopefully kind of just assists in like how you actually do your root cause. To start with kind of observability signals, like we basically want to talk about kind of what the fundamental like different signals in observability are. Uh, so metrics are kind of one of the most basic and fundamental signals you have in observability. Uh, they're really good because you can store really like you can store kind of a lot of aggregate data information like really uh, like efficiently. Uh, they allow you to get kind of a very high level overview of the system. For example, in this case, like this is kind of a graph with for like a database, which is kind of taking in writes. So you have kind of metrics which kind of tell you what kind of how the time series database is actually doing. Uh, so they're great in giving you this high level overview, aggregate information. When you try to drill down, metrics are not always the best. But for the purposes of telling you that something is wrong and alerting, they serve a really great purpose. Uh, but when you actually kind of start talking about root cause, metrics are not always the thing that you use. You really need to go into kind of the realm of logs and traces. So logs are another thing which have been around for a long time. You have kind of different types of logs. Some of them are structured, unstructured, but in general, logs are just essentially statements that you like print out, or you basically print out like as a part of your application. Error logs, debug logs, info logs kind of help you to actually look at different things. Um, in the traditional aspect, kind of when logs were unstructured, they would actually be kind of difficult to use. But over time, like logs have gotten more structured, like with structured logging, with tags, and kind of consistency across different applications. As logs have gotten more consistent across different applications, they've become more useful. You can kind of embed something like a request ID in logs and kind of look at what has happened for a particular request ID. So logs kind of give you kind of the really fine grained, like high granularity information and help you kind of like really do root cause. Combining metrics and logs is still not like super easy. We're going to talk about some of that later. Traces, I would say, are kind of like one step kind of after logs. They are essentially structured logs, but they're kind of structured with around this whole kind of request response structure. So a trace kind of tells you like what happened like at kind of every step of a request as it's kind of made different hops across the system. So traces kind of give you the highest kind of resolution information to debug things, including timing information, errors, payloads, and so on, which basically makes tracing like really expensive. But if you actually have traces and you're able to kind of like store everything, then traces are probably the best way to kind of like debug issues. That said, it's really not really possible to store kind of all your traces just because of like basic storage concerns. So you kind of need to use metrics, traces, and logs in some format together to kind of like figure out kind of what's going, like how things are performing. So kind of from there, like let's kind of talk about what happens when you get alerted now. You have set up these alerts on metrics. When an alert fires, you say you receive a PagerDuty or an email notification. Normally that email notification has some information about kind of what that alert was, some other metadata, labels, information kind of telling you like, oh, like which instance or like where the actual error was. Finally, it may have certain annotations and kind of extra links to kind of tell you, okay, you actually have to go and like look at this particular dashboard, and that's probably hopefully where you can kind of find where something is wrong. So in this email, kind of there's a link to Grafana. So okay, it tells us, okay, let's go to Grafana. Let's look at our current Grafana. Let's see like what's going on. So you kind of come here and you start seeing that, okay, there's some customer requests. It looks like we're seeing a few errors. So that's probably why this alert fired. So let me kind of go and kind of root cause further. So what do you do there? You probably kind of have to go into your like request latency, and you want to go and like figure out kind of what are the tags. So you kind of can go and find the data traces and logs. But the graphs themselves many times don't have kind of a list of all of the tags because you want the graphs to be readable. But to actually search for things within traces and logs, you need some form of these tag information. So once you kind of get these tags, you kind of know, okay, it's this particular endpoint which is having an issue running on this particular host and this particular job. So let me go kind of look at logs or traces to do this. For the purpose of this exercise, because we want to focus on tracing, let's talk about kind of traces. On the right side, essentially here is Jaeger's tracing UI. Jaeger is an open source like tracing solution. It like implements kind of the open tracing, it implements the open tracing trace standard. You can kind of store traces, sample them. So now given these tags, we can actually go and search for these traces. And you can kind of like continue a root cause. So now you kind of know that this is a latency problem. So Jaeger allows you to do some amount of searching around finding a trace which kind of shows higher latency or not. So maybe first we're going to go and find out like let me get a trace which actually like is showing higher latency. Now, if you kind of look at this trace, like it's making a few function calls, it tries to go and hit a particular cache Redis, but then the cache hit fails and it ends up going to MySQL, and here it looks like MySQL is slow, and that actually causes kind of the high latency that we're actually seeing. Now to actually compare, you probably want to see like what a good request looks like. And if you find a good request with lower latency, again, the same function calls, but it actually hits the cache and then it goes and does a bunch of actions after that. So that basically results in lower latency. Now, these are two very simple traces. Just kind of glancing at them, we actually saw what was wrong. But in more complex traces, it's not that easy. So in more complex cases, what you really need is you need kind of a more powerful tool like trace differences, which can actually tell you what is wrong in a particular system. So trace difference is basically looking at the higher latency trace and lower latency trace. It's kind of like differencing them together and kind of showing you which nodes exist or not exist. The red nodes are essentially the ones which don't exist in the first trace. And that kind of tells us that, okay, the second trace actually has a MySQL call, and that's the reason for like the higher latency that we saw. And kind of that's how we kind of know that MySQL is a problem. So kind of summarizing kind of what we did, we went from an alert to a Grafana panel to kind of figuring out tags to traces to finally come to this. But really, can we kind of get there automatically? Like, is it possible to kind of get from an email directly to a trace difference and kind of like skip out through a bunch of these steps, which we have to do kind of on a standard root cause? May not be possible all the time, but at least hopefully in some cases we can kind of achieve that. So it's actually somewhat possible now. It's possible to kind of link metrics and traces together. And there's been a lot of work recently in the open source community on kind of making this possible. So next, we're kind of going to spend some time going over how like metrics and traces can be linked together, and how we can kind of leverage that. So to summarize kind of some of the things we spoke about previously, traces and metrics are generally linked by common tags. Metric has certain tags. You know that that's the particular endpoint or something that you look at, and then you kind of jump into a trace view. You search for the status code or the endpoint, and then based on that, you go and decide, okay, that's how I'm actually looking for traces. But kind of it's possible to jump to a trace directly using kind of some of the newer advances. If you're able to store like representative trace IDs and span IDs kind of alongside metrics themselves, then there's some newer changes in Grafana which kind of allow you to use them as exemplars to kind of directly jump to a trace. Now, how is this actually possible? I think the fundamental kind of the open metrics is basically a standard for metrics emission. The open metrics format is kind of an extension of the Prometheus text format, but it actually allows you to kind of augment a metric with certain other information. There is support for this in the latest Prometheus client, where like along with a metric, you can add these things called exemplars. How we use exemplars, you can use them in various different ways, but essentially it's some context information alongside the metrics themselves. For this purpose, we've taken trace IDs, we've integrated with Jaeger, and for the metrics which come out of Jaeger, we're kind of adding trace IDs and span ID information alongside it. So that kind of gives us, for a metric, we have certain trace and span IDs. And as you see, like even for the error codes and like different latencies in a histogram, we kind of have a representative like trace IDs and span IDs for that particular instance. The next thing which kind of makes all of this possible is kind of open telemetry. It provides a single set of APIs to emit metrics and traces together. These metrics because there's a single kind of SDK, which allows you to emit metrics, traces, and logs at the same time, like using the same SDK. They all kind of share the same context, which makes it kind of easier for metrics to be emitted with tracing context, with an ability to kind of choose which metrics actually get that context. OpenTelemetry kind of supports the open metrics format to ensure trace ID information is kind of also sent to the backend. Now, Prometheus and Grafana, they actually support scraping metrics with exemplars. Prometheus also very recently, just a couple of weeks ago, added support for exemplar storage. So now given a PromQL query, Prometheus supports returning exemplars associated with the series. Still, there's still further work which has to be done there, like handling aggregation functions like sum, max is still under development. And the other thing which kind of like allows all of these things to come together is like the latest Grafana 7.4 now has a way to kind of display Prometheus exemplars as a first-class citizen. I want to talk a little bit about M3 because M3, like I said earlier, is an open source Prometheus kind of remote storage backend. For the part of kind of the demo that I'm going to show and kind of all the work we have done, we basically have worked on adding kind of the ability in M3 to store exemplars kind of alongside metric data points. These are basically stored durable and they're stored for the lifetime of data point. A number of features within M3 are still kind of work in progress, but for the purpose of the demo, like they're there, and we also have links to some of the work in progress repositories for these features. So there's query support to return exemplars alongside data points. And M3 query also kind of ensures at least one representative exemplar is present even after applying aggregation functions like sum and max. So this is really, the aggregation function case is pretty interesting. Now let's consider that you have HTTP errors metric. Now in Prometheus, and you have like 5 different instances which are serving that endpoint. Now in Prometheus, each of those 5 instances come in as individual metrics. So all of them kind of have HTTP request errors and so on. Now, if you get kind of metrics from each of these 5 instances, all of them come with their own kind of like exemplar trace ID information. And they get stored in the backend. Now, when you actually come back and when you kind of retrieve this and you want to do a sum across them, we need some logic to kind of pick kind of which of these exemplars you want to pick. In the error case, it's kind of easy. You just kind of probably want to pick just one of them because they're all representative of some errors. But in certain other cases, like say you have a histogram where you have metrics, like you have metrics and exemplars for kind of different histogram time buckets, then it kind of gets more interesting. What you probably want is you want metrics, you want the exemplars from kind of the higher latency things to show up rather than the lowest latency, or maybe you want metrics to show up from kind of the middle latency. So you have to make like certain such decisions. When you're looking at a max, you probably want like you're basically like the series that you end up picking, you want exemplars from that and so on. So aggregation functions are kind of challenging to deal with. Let's talk a little bit about kind of efficiency and scalability of kind of building the system. Now you have a system which is kind of doing request response. It possibly has kind of thousands or hundreds of thousands of requests in a given time window. Now this app basically, which is getting the requests, is using Open Telemetry to basically send metrics and traces. Now every single data point stored with a single trace ID basically represents thousands of requests because kind of only one of them actually get picked for kind of each time window. But on the tracing side, you really need to store kind of all thousands of these traces to guarantee that the trace ID, which is there, which is stored on the metric, is actually stored, is actually available to query for the tracing side. This is inefficient, like super expensive, and probably just not even feasible to do. So we need to do something to kind of only store the traces that we need and not store anything else. And this is where kind of like what we really want is that we pick kind of one trace per metric and we just store those and we kind of drop everything else from the tracing backend. This is not really easy because kind of traditional trace sampling techniques are are insufficient for this. You cannot really store like all the traces. It's just like way too much memory. Head-based sampling is not really appropriate here because the decision is made before any of the metrics are actually emitted. So you never, like, if you just run head-based sampling for the one single 5xx, which happens like once in a day, you may not get a trace for it, but you'll just get like a ton of traces for the 2xx's. But we really need to store the specific traces that are emitted as exemplars of the metrics. Otherwise, the whole kind of deep linking doesn't really work. So the idea here is you can build a trace holding tier that basically stores all the traces for a short duration. And then kind of with the M3 Prometheus ingestion layer, you kind of indicate from them kind of which traces to actually process. So when they actually process the metric, they call out to this holding tier and say that I want to hold these traces. The ones which are held kind of get pushed into kind of the long-term kind of trace storage backend, and the others just get dropped after that short duration. So you just kind of maintain a short cache, which doesn't kind of increase. So if you kind of put all of these things together, what you really have is you have the app in open telemetry, going to kind of Prometheus and Jaeger, the Jaeger collector. Prometheus kind of sends it through kind of the metric aggregation tier in the M3 case. Jaeger sends it to a trace holding cache, which kind of like maintains all the traces for a short duration. The metric aggregation tier basically decides what traces to keep, what not to keep. It goes and and then it kind of like stores the metric and the trace ID in long-term storage. The trace holding cache, whatever traces get picked, they basically go into kind of the trace and like span storage. And finally, like we query them using kind of Grafana, Jaeger, and whatever alert engine which actually needs access to these. So what does this really enable? What it enables is now you have metrics which are stored, or rather trace IDs which are stored like right alongside the metric. So you can kind of augment and build out like features in Grafana and kind of the places where you visualize and use these metrics to kind of link that for a particular data point, like metric data point, like show me a representative trace, and you can kind of build these extensions. Like I said, Grafana 7.4 kind of has some extensions which support exemplars. So now, given that we have we've built this ability to kind of go from a metric to a trace, like it would be really nice if we can go from an alert to a request comparison directly. We kind of have all of these building blocks. So yeah, this is what we're going to kind of talk about next. We'll first kind of jump into a demo where we're going to look into this, and then we'll kind of jump back into the rest of the slides. So for the purpose of the demo, what we're going to see is we have essentially something which is handling like, we have this email which shows customer, like for customer request errors, like we showed earlier, along with a bunch of the information here, like tags, etc. Also has kind of a trace diff. And this trace diff basically takes us directly to kind of where we where we want to be. This is kind of, instead of the latency case, this is actually an error case where we basically got an error from MySQL, and because we saw those errors, like we returned back, and as a success case, we've actually kind of gone ahead and done everything. So the purpose of the demo, we're basically running this Jaeger utility called like Hot Rod, and Hot Rod kind of has it's just kind of like simulating like certain like request responses. So just kind of to show you kind of like how the whole experience can work is like, now say, yeah, so the 5xx's are kind of this orange line. So you want to see for this 5xx, like you can actually see the trace related to the 5xx and kind of what happened here. So it's kind of showing some errors here. Now you want to next go and kind of compare the 5xx and see like what it does. We basically made an assumption here that the 2xx's are the nice things, are your base for comparison, and that's how this demo has been set up. But we can imagine like just picking kind of two different metrics, two different time series, and doing a trace difference for them, also being a different possible workflow. So showing this diff, this is kind of the similar diff. So in this case, I guess MySQL returned errors. So we went to the Redis cache, it failed there. We went to MySQL, it returned an error. So that's why the 5xx does not have kind of other kind of customer nodes in them. And yeah, so those are kind of the things. Here we have kind of request latency histogram, where we have like the 1 second and you want to show a diff against kind of a faster trace. Okay, I'm not sure why this did not work, but let's see. Okay, this should actually work. So this is kind of one of the previous ones where we saw where kind of MySQL came in and kind of slowed up the request. So yeah, this is actually kind of feasible to do now. Jumping back to our presentation. Give me a moment. Share screen again. So how was kind of this demo possible? We basically leverage open telemetry and open metrics to like limit metrics with trace IDs as exemplars. We leverage kind of Prometheus and M3 support to scrape and store exemplars alongside these metric data points. And then finally, we kind of built contextual links into the systems consuming trace and metric information. The empty query response, when it comes back, along with these metrics, it kind of returns, and the values, it returns kind of the span ID and trace ID. And you can kind of use this information to better kind of, you can kind of use this information to better create like these contextual links. Now, there are a few challenges here, obviously. This is kind of one of the, one of the mechanisms we thought, which may be a nice thing to do, is like, how do you kind of select a good and bad source for traces? So one way to do that is you kind of build an extension, which allows you to select a trace as being a control trace or kind of a control metric. And then when you pick kind of any other trace in the system or any other metric in the system, you can kind of have it do a trace comparison with kind of whatever you consider your control trace. So really, it's about building like different contextual links with this kind of basic support of deep linking metrics and traces. For graphing interactions, you can configure a metric that can act as a source of good exemplars, like we showed you. For alerting integrations, you again provide an ability to configure a metric that can act as a good source of exemplars, which is what we kind of did in our like changes that we made to Alert Manager, where kind of have a metric where you're alerting on, and then a metric where you use kind of the source of say goodness, and then you compare both of them as this. In some cases, it's actually possible, like if you have like standard well-named metrics, like RPC metrics, where you know kind of the difference between success and different errors, you can potentially build plugins that automatically detect and provide comparisons based on knowledge of these metrics emitted. But yeah, so once we kind of have these building blocks, there are a lot of things we can do to kind of make use of these building blocks to create like a really important product. Kind of just to summarize this, like to say kind of trace differences are a really powerful tool to debug issues. Using deep linking support kind of between metric data points and traces, we can kind of build a number of integrations that can help us speed up root cause. And yeah, there's going to be a lot more work in this area coming out over the next few months. And yeah, it's really exciting. It's really exciting times. So where are we with kind of all this work? The current end-to-end demo is at this link. A few kind of the major PRs is like the work to kind of add exemplar support to open metrics and Prometheus. Adding exemplar support in kind of the Prometheus client, which was done by Bjorn from Grafana. And there's been work on kind of like how do you store exemplars in Prometheus memory, which is done by Callum from Grafana. This last diff is like super recent. It's actually just been a couple of weeks since it's landed. So I actually haven't gotten a chance to like play with this yet, but it's really kind of exciting times. Some resources, we'll share out the slides, and yeah, these resources are kind of like useful to kind of read up more about kind of all of these different technologies we spoke about. And yeah, that's the end of the talk. And yeah, thank you so much for like having me here and like letting me kind of like talk a little bit about kind of observability and like some of the latest things that we have out there. And happy to kind of take any of your questions you have at this point.